All right. In this lecture, we're going to be talking about soil salinity or soil, how much salt is within our soil. There are many different things that impact the amount of salt within a soil, but the main thing is the precipitation in that area. So, salt buildup occurs when precipitation is less than evaporation. And that means where very little precipitation occurs. Because when very little precipitation occurs in that area, there's not going to be enough, or there's not going to be a lot of water to be leaching through that soil to leach out the salts. So, very little water equals salt buildup. And then where acidic areas occurs when precipitation is greater than the evaporation. So there's going to be a lot of leaching that's going to be occurring. So where else do these salts come from? It can come from irrigation water. So with irrigation water, sometimes you have high amounts of salt in the water. So if you use salt or saline water to irrigate your plants with, that's what the soil is going to retain. And it's also going to have a lot of salt as well. Here's a big one we all use, especially in Ohio. We use de-icing salts, right? So, the snow will melt so we won't slip. But we don't really realize the effects of these de-icing salts. The de-icing salts, yes, they go on the ground, but once the de-icing salts come on the plant material and that gets absorbed into the soil, then the soil also contains salt as well, increasing the amount of soluble salts within the soil. So our city water may have high salt as well. Usually the city water is regulated, which is really nice compared to having a well or anything like that. The city water needs to be tested and has certain amounts of salt levels that are within the soil. But you can still get city water that has high salts as well. So you just have to really monitor the city water that you use, any water that you use, before you irrigate your plants. And that's testing the water for soluble salts. And then we also have another one, fertilizers. So fertilizers that can be used a lot of times will have high salt index, which you need to be very careful of, especially the quick release fertilizers. They are going to have a lot of salts within them compared to more of the slow release products that will have less salts, but they still have salts within the fertilizer. So really monitoring how much fertilizer is put down, and you only apply fertilizer when your soil test recommends it after you either send it out to a lab or you do an in-house test on that. So you may be asking yourself, yeah, my soil has a lot of salt in it, but what does it actually do? Like, what's the problem with having a lot of salt within your soil? So the main effect here is that osmotic effects within salts, and that's when the charged ions of salt pull on the water. So what we initially want, overall, we want that water to go to different soil particles that really need it, right? So that water needs to be getting pulled to soil particles so that soil particles could retain it and then give it to, the different, the plant roots because that's what we want. Whenever you put salt into it, the salt or the water particles are more pulled towards the salt. So in this case, instead of it going towards the soil particles that get, pulled up from the roots of the plant, it's going towards the salt. And it's making the soils dry up a lot more quick whenever you have high salt content. Okay, so you may be wondering, how do we figure out the amount of salts that are within our soil? So that is called electrical conductivity, or EC. So we learned to test the pH of the soil. We run a pH test. Here we run an EC test, and the EC is going to measure millimoles per centimeter. And that's the amount of salt that's within that soil, or the amount of salt within the water. And that is the soil solution, the water mixed with the amount of soil. So here's just a couple different electrical conductivity or EC meters that you can use. So the one to the left, it's almost as a pen that you could take. It's very mobile, which is nice. So you could take this into the field and do an EC test very easily. We are going to be using a meter such as this one, just because it's very easy to calibrate and it's very easy to use. Now the middle one has a probe, and this one is still very easy to use, easy to calibrate and whatnot. But the only issue here is the one in the middle, you're not going to want to take this into the field. So it's not that practical in a lab setting. It's perfectly fine. But in the field, you want something that's smaller and easy to use. And the last one is not so practical as well. And you wouldn't really take this one into the field. And this is not digital either. The other two are digital. Now, when you're looking at EC measures, this is just a standard, but if it's anywhere from 0 to 2 millimoles per centimeter, that's, no issues there whatsoever. Anything above that, you're going to experience some issues. So 2 to 4 millimoles per centimeter, the yields of sensitive crops are going to be a lot lower. So they're not going to produce and be as productive as non-saline soils or soils with very low salts within them. If it goes from 4 to 8 millimoles, then the yields of most crops are going to be a lot lowered. 8 to 16, that is extreme amounts of salts within your soil. So only salt tolerant crops will yield well. And then anything above that 16, only the most tolerant will yield anything whatsoever. In my experience, I've seen very little plant or very little soils that come back anywhere from 4 and up. So I don't usually see that, but usually it comes back around 2. But if you're having salt issues, it's anything above 2 that you will raise a red flag to. Now, the different types of saline soils or salted soils that we're going to talk about is the saline soil and the sodic soil, or the combination of the saline and sodic soil. So some things to remember within a saline soil: it will have an EC measure of 4 millimoles per centimeter or more. And then it's going to have a pH of 8.0 or less. And this has more calcium, magnesium compared to sodium. Now, a sodic soil is going to have an EC measure of 4 millimoles or more, but is going to have a pH of 8.0 or more. And this has more sodium than calcium and magnesium. Now, let's look at some examples of salt damage. Now, here we can see those big white patches of salt, and that's the salts actually leaching to the soil surface. And you can see not a lot of plants are growing in that area because there's so much salt that's accumulating. And also we have the soil that is cracking. It's cracking because it's so dry. It has so much salt content that any amount of water that's being pulled here, it's going pulled right to the salt, and that's drying out the soil completely. Salts can also burn plant tissue. Now, we talked about how when salts are within a soil, any water that goes to it, it will absorb it and cause burn. But on plants, it will burn it completely. It's absorbing all of the moisture here and burning the plant tissue. So here, I'm sure there was a case of de-icing salts that were put on the sidewalk. And then when these de-icing salts were put there, there might have been snow pileup. So after the salts were put down, maybe there was snow and it was shoveled. And here it was on the plant tissues, and it burned it completely. So you can also see how uniform it is, right? It's very uniform distribution, making it a potential abiotic issue. And here's just another photo of that salt damage, and it comes down to planting species that are salt tolerant, especially by sidewalks and roadways and your driveway and whatnot. Here's another one. I don't know if you guys have ever seen this, but driving down the road, you see a lot of, either yellow or brown trees, the whole entire tree covering it. And sometimes it's really interesting because you could see just like the one side that's facing the road, it's completely burned, and the other side is, healthy. It's because the salt um, was exposed to just the side of the tree that's facing the road, and that's what burned it. See, we could see a common factor, and that's all of the plants that have been affected. It's by roadways, it's by sidewalks, and this is mainly because of those de-icing salts. So here's another issue that's occurring, and if you could see these branches, it has like a proliferation of branches coming out of those central stems. Those are actually called witch brooming, and this witch brooming is caused by there was salt in those areas. So whenever that salt burned it, those certain areas, it started producing an abundant amount of shoots in that one area because it was burned. It was essentially like someone cutting back an area. And after you cut it, those branches are going to sporadically come out in shoots. So this is what you see as witch brooming, and that's on the tips of the terminal branches as well. So, just some common things to determine salt damage. This starts to show in early spring. You're going to see this. And it progresses through spring, not necessarily getting better. It has brown margins on deciduous trees. So, you're going to see that brown margins around the perimeter of the foliage. And then with needles, it's going to have that brown tips on those needles. So there are ways to manage salt damage in the landscape. We talked about planting salt or not planting salt sensitive plants over here, over where there's going to be, the sidewalks or the roadways where there's going to be de-icing salts. You want to plant salt tolerant plants, so it could tolerate these issues. Also, if you have an area that has high salts, or it has been exposed to de-icing salts, flush that soil. So flushing the soil, it is very simple. Water it. And you could water this by applying at least 2 inches of water over a 2 to 3 hour period, and then stopping if runoff does occur. And then keep on flushing that. If you flush the soil, it's going to flush those salts out of it. And then you can also mulch. Mulching prevents the evaporation and the buildup of salt within the soil, so that would be fine. You can do 2 inches of hardwood bark mulch, and that could reduce the amount of salt buildup within the soil. Instead of doing overhead irrigation, you can do drip irrigation. And doing drip irrigation, it really focuses the water around the root system. So if you focus the water within the root systems, it's going to get pulled to the roots first, not to the actual salts within the soil. So you could do drip irrigation compared to overhead irrigation. With overhead irrigation, it's not necessarily focused on the roots itself. It's more focused on the whole area of the area where you want to get irrigated. And lastly, you could apply gypsum to reduce the amount of salt within the soil. And you could do this, and you could even do this as a preventative, but reactive approach, you could fix or repair salt damage by applying gypsum.